Aloha, everyone. I'm your host, Christine Laney Mitri, and welcome to Smart Living Hawaii's podcast, where we discuss smart homes and technology, sustainability, healthy lifestyles, and smart business. Today, we're going to continue our Sustainable Leaders series, and we're going to talk story with Neil Sims. He's the founder and CEO of Ocean Era Inc. We will learn more about fisheries, farming fish and limu, and the innovative work he is doing in this space to be more sustainable, regenerative, and kind to the environment we live in. Aloha, Neil.
Aloha, Christina.
Thank you for joining us today. You're in Kona, is that right?
Yes, I'm based. Our company's based here at the Natural Energy Laboratory, just next to the airport in Kehole in Kona.
And before we begin, I'm going to just give you a little quick snippet of his bio here. Actually, I'm going to read the whole thing. Here we go. Neil is the founder and CEO of Ocean Era Inc. It's in Kona, as we mentioned, working in developing offshore culture systems for marine finfish, such as kampachi, snappers, mahimahi, and herbivorous reef fish, tropical microalgae, and exploring microbial biodigestion. Oh, sorry, my bad. Microbial biodigestion of microalgae, which you will have to explain in more detail for us.
Sure.
Neil was also born in Australia, hence his accent that I could hear over there, working and initially in marine resource management in the Cook Islands. He has lived in Kona for over the last 30 years, working for a series of startups at the Natural Energy Laboratory of Hawaii, initially in pearl oyster hatchery systems and pearl farm development, and then in marine fish hatchery production and offshore aquaculture. Neil has founded commercial offshore kampachi farms in Hawaii and Mexico. He led the Valella project, an untethered offshore drifter pen, which we're going to explain a little bit more in detail, and an unmanned net pin operation in 2,000 meters of water, 10 kilometers offshore. Ocean Era is planning to deploy an offshore microalgae array in Kona and is applying for permits for an offshore fish and microalgae farm on Oahu. And I know we're going to be diving into that as well, along with the Gulf of Mexico off of Florida. Neil sits on Aquaculture Stewardship Council's technical advisory group and is a NELHA board member. He holds a BS Marine Biology from James Cook University in Queensland and an MS in Zoology from the University of New South Wales in Australia. So that pretty much covers a lot that we will be discussing to give you a preface. But I like to share your background and growing up for our listeners before we start.
Sure, Christina. So I was born out in the outback of Australia, but my mother had grown up on the coast. And when I was about 2 years old, she had three boys around her ankles. And so she insisted that we move back to the coast. And so I grew up literally 1.5 stone throws away from the beach in Australia. And I misspent my entire youth down on the beach, surfing and swimming and snorkeling, sailing. And so I also had an interest in biology, had an ant farm, had a butterfly collection. And so it seemed natural for me to go and pursue marine biology. Back in the time, you came out with a degree, an undergraduate degree in marine biology, and mostly you would either go and work for the government or you'd work for a university. But I rolled the dice and joined the Australian version of the Peace Corps and ended up out in the Cook Islands teaching. I'd never taught before, but I come from a family of teachers. I taught for 2 years in Mangaya, the southernmost of the Cook Islands, which is a wonderful experience, an island of 1,500 people that spent a lot of time in the water spearfishing because a lot of it was subsistence living. But after I'd finished up there, I traveled for a while and then literally hurled myself at the fisheries department in the Cook Islands, the Ministry of Marine Resources, and said, please put me to use. And so they offered me a job there. And as the head of fisheries research, I had no real experience, but that they said that they needed a fisheries research division. So I was it. And initially, a lot of my work was focused on trying to manage the commercial fisheries there, because that's sort of what draws your attention. What's fisheries are, as a biologist, there's some real challenges in there. And so for the pearl shell fishery, or the giant clam fishery, or the trocus snail, which is a snail on the reef that has a pearly shell, you know, these were really high value fisheries for these outer islands that, apart from these fisheries, all else they had was making copra from coconuts, and that's a miserable way to make a living. And so there were some real challenges around trying to set up management regimes for these fisheries, where when I'd been in Malaya or on the other islands that didn't have commercial fisheries, you didn't need to really manage the fisheries there, because it was subsistence, and there was some natural balances in place there. In a subsistence fishery, you can only eat so much. But once you put a dollar value on a common property resource, then all of the alignment gets skewed. People want to take more than their fair share. And if you let them, they'll take a lot more than their fair share. I found this really discouraging. Whilst we were working on this, there was a lot of close contact between the Cook Islands and French Polynesia, Tahiti and the Tuamotu Islands, the atoll islands north of Tahiti. There's a lot of family and cultural connections between those islands. And over in French Polynesia, they were starting to develop the black pearl farming industry, which was just amazing in that you could actually farm pearls. And so instead of just killing a pearl shell oyster and selling it for the value of its shell, if you actually took that oyster and you put it onto a farm and you nurtured it and you kept it clean and got it growing vigorously, and then you brought in a pearl seeding technician that would implant the pearl nucleus into that oyster, you'd wait for 2 years and you'd keep tending to that oyster and keeping it happy. And within 2 years, then you could harvest a pearl. And whereas the pearl shell value at the time, the pearl shell value was maybe $2 US for a good quality shell, the pearl was worth over $80 per piece. And then you still had the oyster. This made incredible sense to me. This was increasing the profusion, the providence of the oceans, rather than just taking what we could. We were starting to give back. And so over the remainder of my time there, until I left at the end of 19, I left at the end of 1988. During my time there, I was very much focused on trying to develop aquaculture for these industries, either pearl farming or hatchery production for the giant clams or for the trocus. It seemed to me that when you are able to increase the provenance from the oceans, that you're really aligning there a lot of the incentives for folks then. If you work harder, if you grow your pearl farm, you will have more money and there will be more oysters, and they will be still spawning and spreading their spat fall out throughout the rest of the lagoon. It's aligning the economic incentives with the ecological incentives. And that's what I find aquaculture in all of its myriad forms, when it's done well, that's what it does. And so from that position there, I came and I worked here, went back to Australia for a year, but then wanted to be working in the Pacific Islands, and started working in pearl oyster hatchery development, using a hatchery to actually increase the number of pearl oysters that you could have. And we tried to get a pearl farm established here in Hawaii. We built a pearl oyster hatchery down in the Marshall Islands and in the Philippines, and was involved in a pearl farm project back in Australia.
Didn't we have pearls in Pearl Harbor? Was it?
Indeed, we did. Want to guess what happened to those, Christina? We
Looking out the
overfished
harbor.
them. Yeah,
And I'm
Pearl Harbor.
at it right now, and I'm like, we clean up the harbor and the path, and it's so contaminated that we're not even no one can even fish in it now. So
Yeah.
that
That's a classic example of what happened to pearl oyster stocks throughout most places in the South Pacific where you have a shallow lagoon or bay. Pearl Harbor, Kaneohe Bay, Christmas Island, straight south of here, uh, Pearl and Hermes Reef to the northwest. Wherever the pearl shell was readily accessible, folks would get in and clean it out. The only places, and the stocks would be wiped out and they wouldn't come back. The only places where pearl oysters still remained in some abundance is where there were deep water reserves in some of the lagoons in French Polynesia and the Cook Islands, where it was really difficult for divers to get to those.
hmm.
So this is a classic example of what humans will do when the economic incentives and environmental incentives are misaligned. We will hunt things down to extinction. And it's fairly discouraging to be involved in administering that, trying to manage that sort of a pillage and plunder. Whereas developing aquaculture, producing more of the marine organisms that we crave, that is a path that really, to me, really has heart. And so the pearl oysters were very, very good to us for many years. But around about the turn of the century, around about 2000, kind of felt the firm hand of fate in the middle of my back because for years, I'd still been tracking what was happening with commercial fishing around the planet and just watching the albacore fisheries off the California coast crashed. The North Atlantic cod stocks crashed. Uh, there's just been innumerable instances of where fish stocks, even where people thought they were managing them very well, where the stocks eventually crashed. And so it really felt like we could sit here and keep playing with pearl oysters for the rest of my career, and it would have been wonderful. Would have been a lot of fun. But what would I tell my grandchildren when they said, well, okay, Grandpa, you knew that the ocean's resources were being plundered beyond their sustainable limits. What did you do? Oh, I kept playing with pearl oysters and growing pearls. It was a lot of fun. That's what you did, Grandpa. Great. So it felt like we needed to be doing something that was more meaningful, more impactful. And what is there that's more impactful for human existence than food? And particularly seafood, great tasting seafood. It's what we crave. We go to sushi restaurants, we go to seafood restaurants. It brings people together. It's really nourishing. Your doctor is telling you you should be eating more seafood. And it's very clear that we can't get the amount of seafood that we need to feed 10 billion people. And when they're all understanding more the increasing importance of seafood in their health. So people are trying to increase their personal consumption of seafood, and people are also having more disposable income as there's a general increase in global standards of living, and so people have the spending power to be able to go and buy more seafood. We can't rely on wild stocks to meet this. There's a massive shortfall. Already, over half of the seafood that's consumed around the planet is farmed, and the other half is wild. But that percentage of amount of wild fish, it's about 80 million metric tons. That can't be increased very much, marginally. Even if in an ideal world, the estimates are that if you had an ideal management regime over global fish stocks everywhere, maybe you could get another 15% increase out of the wild stocks. So we can't just rely on wild fishing anymore. We have to figure out how to grow the seafood that we crave. And if we come to that realization, then it's not a question of do we do aquaculture or do we do more wild fishing? No, we have to do aquaculture. We just have to figure out how to do it in a more environmentally responsible, a more scalable manner to be able to meet these
Yeah.
projections.
So why don't we talk about now? There's a lot of people, even to this day, that are not very aware of, let's just get into Atlantic salmon, for example, there that are farm raised. A lot of people do not know that it's bad. I mean, most people across the board genuinely know that salmon is good for you and you want your omega-3 fatty acids. And so they're starting to learn, like, oh, it's good to eat salmon. So then that's what they know. Um, Out of the people that have, dug a little deeper, or maybe they're in sustainability, they know a little bit more about farm raised and what that means and how, that translates to, and I don't even know this, but you could tell it in the taste of the food. But maybe we could just explain a little bit of, you know, what has happened with maybe the salmon industry on farm raised, and what's the big talk about it? Why is it not as good, or why is it bad for the environment? Because a lot of people do not know this, like they really don't. And the people that do know this don't realize that there are alternatives, like the innovations that you guys are working on. So yeah.
Yeah. Uh, let me just pick a couple of bones with it there, Christina. I mean, you'd said that farmed salmon is bad for the environment. I think generally, so long as folk are farming the salmon in a responsible manner, it's the least impactful form of animal protein production that there is. And this was recently validated by another study by the group FAIRR, FAIR, that they have their investor group, venture fund group that has a global assessment of all of what is the most sustainable form of animal proteins. And of the top 10 companies, 7 of them farm Atlantic salmon. And that's an objective evaluation of if you're going to eat meat, and you can't mandate that everybody on the planet should be vegan or vegetarian. People are going to want to eat meat. If you're going to eat meat, the least impactful thing that you can do is to eat seafood, probably farmed seafood, and according to this recent study, farmed Atlantic salmon. And actually, it's, of course, if you're eating Atlantic salmon, it's almost invariably going to be farmed. Why is that? Well, we wiped out the wild Atlantic salmon stocks. We literally hunted them down almost to extinction. Well, we hunted them down because they're really easy to overfish salmon. But then we put in dams and weirs, and we dredged the rivers, and we pumped our pollutants into the rivers. We did that to the wild stocks. So now you have over 2 million tons a year of farmed salmon. The majority of that is farmed Atlantic salmon. And most of that is raised in a very responsible, very low impact manner. Fish are really efficient at converting their feed, their metabolic process of converting feed into flesh, because they're cold blooded, so they're not spending energy maintaining their higher body temperature. And they don't have to stand up. They don't spend energy stand up. They float in the middle of the water. The reputation that the scuzzy reputation that surrounds farmed salmon comes from a number of areas. That for many years there was an active demarketing campaign around farmed salmon by, surprise, surprise, the commercial salmon fishing industry, and from NGOs that were being very short-sighted. They were looking at the problems that Atlantic salmon had. There were a number of problems that they need to address, but they weren't thinking about, compared with the alternatives, and what else are we going to eat. Farmed salmon has been around for 50 or 60 years. Most of the other animals that we farm, we've been farming them for thousands of years. And so when they first started farming salmon, they didn't really understand what engineering they should need to keep the fish in the net pens. They didn't really understand the nutritional requirements. They were literally feeding chopped up fish to the salmon. They didn't really have a very good understanding of the ocean flux and where you'd be getting good currents and good oxygenation. And they didn't have a good understanding about animal health and how they should be caring for the fish. But over the last 40 or 50 years, there's been a phenomenal improvement in those, in the understanding around those parameters, so that now I think your listeners should be eating farm salmon with gusto, with a clean conscience. Okay, if you're really concerned about where your farm salmon is coming from, then go on to one of the certification schemes. The Aquaculture Stewardship Council is one that I'm actively involved in for the technical advisory group, as you've mentioned. And then there's other certification schemes there as well, the Global Aquaculture Alliance and Global GAP in Europe, the European certification scheme. Most of those are now certifying farms, salmon farms, and the criteria that they use, particularly for Aquaculture Stewardship Council, they're very rigorous criteria. It's from the criteria are established from multi-stakeholder input, which included a lot of NGOs. And so you have the situation now where most of the science-driven ENGOs, environmental NGO organizations like WWF and Conservation International and the Nature Conservancy, an Environmental Defense Fund, most of those are now saying, looking at the landscape of the global impact of food on our planet and saying, we need more aquaculture. Whereas back 10 or 20 years ago, they were saying, oh, salmon farming, we really don't like salmon farming. We really wish it would go away. Or aquaculture has a lot of problems. Now they're saying, actually, we need to be encouraging the right forms of aquaculture. And actually, when you look at it all on the net salmon farming, when it's done responsibly, is very low impact. I think that extends them to a lot of the other work that we are doing with offshore aquaculture. One of the ways that you can minimize the impact of any fish net pen operation is to put it out into deeper water further offshore, where there's less connection between the fish on the inside of the pen and the fish and the corals and the rest of the ecosystem that's on the outside of the pen. And that's what we've been pioneering here in Kona. We don't run the offshore kampachi farm here anymore. We ran that from 2005 through to 2009. And then the global financial crisis came.
Before we get into that, I guess I did have some, I don't know if it's myth or not, but I know that people have talked about, maybe you could help dispel them if so.
Sure,
but like
sure.
When it comes to salmon that's farm raised, people say that the salmon is gray colored in skin and they have to do something to it to make it orange, and it's like very light pink and it's not really the right color, and they have to dye it or something. I don't know what that means. I mean, I don't know. I've heard that before. I've heard that they need antibiotics or they need to be pumping the fish with certain things, and maybe it's in their feed or what they have to do in order for them to not be getting certain types of illnesses or diseases or whatnot. And then there's sea lice, and then there's like, I don't know, there's just like a lot of these things that ends up, coming up that, I mean, is it really true, or is it just like on rare occasions, or does this happen? I don't know. I mean, it's what we hear, and I don't know how. Yeah, I guess it would be helpful to hear your perspective.
Sure. Turn the dial down if I get too animated here, Christine. But no, I hear this a lot, and some of these fears are founded in elements of truth, but they might be elements of truth from 40 or 50 years ago, or even some of it perhaps even 20 years ago. We've gotten a lot better. The science that underpins a lot of what we do with aquaculture has become a lot better in the last 10 or 20 years. Back when I first got involved in fish farming, a lot of the fish farmers were feeding their fish with something that was 60% or more of it was Peruvian anchoveta, either fish meal or fish oil that came from Peruvian anchovies. And quite rightly, the environmental community was wringing their hands and saying, oh, this isn't, well, they were saying that this is not scalable, and they're also saying it's not sustainable. It is a sustainable thing to do at that scale where we were 20 years ago. It's sustainable in the sense that you could keep doing that, but it's not scalable. We can't keep feeding Peruvian anchovies and grow the aquaculture industry the way we need to feed 10 billion people. We need to find alternative sources of proteins and oils. And the aquaculture industry, particularly the salmon farming industry, because that has been the most profitable of the fish farming industries globally, they've been relentless in their research work over the last 20 years to where now most of the salmon is 10% fish meal or less. And that fish meal is often from processing byproducts from other fisheries, from wild caught fisheries. And so it is very, very low impact in the feeds there. You talked about the color question that's in there, and that's something that people will often wring their hands at. Oh, you know, farmed salmon is grey unless you feed it a particular carotenoid. Well, so a wild salmon, if they're not getting that carotenoid in their diet, so if you're going to feed a balanced nutritional diet to a farmed salmon, you have to include that carotenoid in there. It's not, people will call it a dye. That's absolute slander. It is a naturally occurring carotenoid that it's the same thing essentially that gives carrots their bright orange color. It's naturally occurring.
So I have a quick
The
question.
question about antibiotics. I'm sorry, Christina, I'm not going to let
Oh,
you
yeah.
go. The question about antibiotics is, yeah, 30 or 40 years ago, there was a lot of misuse of antibiotics in aquaculture because people didn't understand the long-term risks around the selective pressure for resistance to antibiotics, and they didn't understand the environmental impacts from overuse of antibiotics. And it seemed like that they had, because they didn't understand the engineering or the nutrition or the other physiological requirements of the fish, there are a lot of diseases around the salmon that they were farming then. But this was when they were farming them in shallow protected bays because they had crappy engineering and they were crappy nutrition. They're trying to figure this out. No farmer that I know on the planet wants to feed, except for pig farmers and beef farmers and some poultry farmers. You have, up until about 3 years ago, you were permitted to feed antibiotics to your cows, your pigs, or your chickens, and nobody squealed about that at all. You could go and buy
Except for the
5 or
pigs.
10 pounds of oxytetracycline off the feed counter here, the feed store here in Hawaii, and feed it to your pigs or your chickens. Nobody paid any attention to that. Now it's now restricted, but in aquaculture, particularly in the US, the use of antibiotics has always been very tightly restricted, and no aquaculture farmer, no fish farmer wants to be using antibiotics because it's a band-aid approach. You're not, if you need to use antibiotics, you're not taking good care of your fish. And it's a fundamental problem, and it becomes a drug addiction problem. So every fish farmer that I know, if they have a bacterial issue with their fish, their first response is, okay, let me get my fish healthy again. Okay, if I need to use a short dose of antibiotics to get them over that issue, then yes, I'll do that. But let me find out what is the underlying physiological cause here that is rendering my fish vulnerable to this bacteria. And they will strive relentlessly towards that. And pretty much universally now, they will also go to vaccines because most of the bacteria that found in fish farming, that it's a lot more effective to use a vaccine to ramp up the immune system, the natural immune system in the fish itself. And so vaccinations and better farming methods are now universally, that's where people will strive towards. And so aquaculture now uses less antibiotics than any other animal protein production system, short of course, the organic systems that are out there that don't use antibiotics. There's a beautiful graph that I can't find the copy of it here now. I'm looking on my pin boards, but it's a graph of the use of antibiotics and the volume of production of salmon in Norway. And as the volume of production in salmon increases, like it hits a hockey stick, and it's up over 1 million tons a year now. Initially, back in the 1980s, there's a very high use of antibiotics. But then as the industry grew, the use of antibiotics plummeted until now it is minuscule amount that they use because they've got better engineering systems, better nutrition, better understanding of fish health.
Yeah.
Like I
So
said, you can cut me off when I get too long on a
no,
rant, Christine.
I think it's very good and helpful for people to like see the bigger picture and how things are. And maybe people could do a little more research on their own to, really see what it is they want to believe. And what's the truth behind everything. Because I think a lot of times people want to know that if they're just, hearing things, how true is it? And where is it coming from? So this one thing I do want to ask because I do get this one salmon from Sam's Club and it's very expensive. It is farm raised. It's a king salmon. But it's very expensive and it's from New Zealand. And the color's always there. It's got a lot of fat in it. It's probably like one of the best salmons I've ever eaten. Because even the wild salmon, I mean, it's not as fatty. I guess that's probably why. But I'm just trying to figure out, well, those ones are farm raised. Is New Zealand making better, doing it better, or is it because of the type of salmon, in comparison to the other stuff they're selling for like a third the cost? I mean, it really is like $10.99 a pound versus $30 a pound. It's like it's way different in price. I didn't know if you knew.
Yeah, I haven't ever eaten any of the New Zealand king salmon, but I've heard about it. And some of my former colleagues who work here now work in the New Zealand salmon farming industry. And my understanding is that the reason why it is so high priced, king salmon are more expensive to farm than Atlantic salmon. Atlantic salmon are phenomenal in terms of their growth rate and their efficiency at converting feed over and the size that they will get to. Whereas understand, please, I'm a tropical marine biologist. So when I
Sorry.
start talking about salmon, I'm kind of out of my depth. I'm in cold water, as it were.
Sorry.
But my understanding is that that's why most of the commercial salmon farming is Atlantic salmon. Now, there is a curious thing here. A lot of people will wring their hands when they think about salmon farming and think about, the problem of escapes. If you're farming Atlantic salmons, they're going to escape and get established in the rivers and wipe out all of the native salmon. Back in the 1940s and 1950s, the Canadian government had an active campaign to try, because Atlantic salmon are a bigger salmon and people found them more attractive, they had an active campaign to try and introduce Atlantic salmon into the Pacific coast of Canada, repeatedly taking salmon across there and letting them loose in the rivers, and they never became established. Atlantic salmon have never become established in Chile, where they were not native. They've never become established in Tasmania, where they are farmed extensively. They are lousy colonizers. They do not colonize new rivers. And so when people start telling you, Christina, as they will, the horrors of a salmon escapes, they're going to go, that's not Atlantic salmon. The Pacific salmon are very, very good at colonizing. And so that's why down in Chile, where they're farming the other kinds of salmon, cohos and others, well, they've become established in the rivers. In Australia and New Zealand, the other salmons have become established. So actually, if you're really concerned about the potential environmental impacts of salmon, you really should be asking people to be farming Atlantic salmon.
Interesting. Okay, we are moving on from Atlantic salmon into the tropical shores of what kampachi and snapper and some limu and stuff. So I just want to switch gears. I did want to cover this because I know that I mean, hey, if you go into Costco or Sam's Club nowadays, I mean, there's like rows of salmon. I'm just like, and then I'm like, why is this so cheap? But anyhow, now we have a little bit more grasp on it, and maybe might open some eyes, give some people some time to go do their own studies because they might want to look up this a little bit more. But let's move into what you're doing here. I know in the bio we were talking about you having some pins that you are working on and getting some offshore pins of which are more like sea stations, or what would you call them? Is it a sea station?
Yes, the net pens used on the farm here in Kona, it's just out the window over my shoulder here. Even though we're not involved in that farm operation anymore, it's the company Blue Ocean Mariculture now manages that operation. We really admire what they do. They've continued on when we had to sell it in 2009 because our investors were heavily exposed in the global financial crisis. They're exposed to real estate. And so we weren't yet profitable. We were only at 500 tons a year, which at the time we thought, wow, this is great. But really, you do the analysis, and you need to be at probably 1,500 or 2,000 tons a year to get to profitability. And that's not unusual. It's the same as if you've got a dairy farmer with 5 cows. He's not going to stay in business very long. You've really got to have 50 or 80 or 100 cows before your dairy farm is actually profitable. So there is a question of scale in there. And so we weren't yet at the scale where it was profitable. And so others came in and took over the operation and continued to run it. And it still is running to this day. Now that it's almost 20 years of operation that it's been out there. Interestingly, in terms of the people's concerns about environmental impact, it's about a half a mile offshore, and directly inshore from the Kampachi farm here is probably the best manta dive site in Kona. And so at any night, you'll have 10, 15, sometimes 20 boats out there with tourists or with locals just diving with the mantas. And people will also dive there in the afternoon before the manta diving starts. And so there's a lot of eyes on that reef. And over the 20 years that that farm has been out operating there offshore of Kona, just a half a mile away from that reef, there's been no discernible impact on that reef there. And that's also validated by some of the coral studies that the state government biologists have been doing as well. That
Does it move?
operation continues.
Do
No,
you,
it's moored.
it's
It's moored
fish?
in place. So it's like a big grid with anchors on each side coming up, and then like a tic-tac-toe grid in the middle, where wherever you've got a tic-tac-toe square, you've got a net pen or a sea station. You're correct. The kind of pens that they use here in Kona are a sea station, and they have that big steel spar in the center and then that tent-like structure. They're able to raise them up out of the water, halfway out of the water for some of the time, which they do that to dry the netting and keep the netting clean. And that's a great net pen system. We've also, in the offshore farm that we built down in La Paz in the Sea of Cortez in Mexico, we used another kind of system which is similar to the traditional salmon net pens, the black rings of pipe, which are great because they're really flexible in the ocean. But then it will also have like a submarine ballast on the bottom of it, so you can submerge them and then raise them up to the surface when you want them.
So
It's
the one
great to
in
be able to
Kona,
submerge.
it doesn't submerge. It sits on the top.
No, it can. That central steel spar is like a submarine ballast, and so you flood it,
Um,
you blow the air out of it, and it will submerge down to 12 meters, 35, 40 feet below the surface. And then to raise it back up, you come and you pump air into that chamber, and it raises back up again.
what
And then
is
the
a
same also for
normal,
the
where do you normally keep it just in general? Is there a certain like depth?
normally it will be submerged where the top of the pen is about 35 feet below the surface, and so the cage is another uh, 80 feet deep, and so the bottom of the cage will be down at 110 feet or so. And these cages are shaped like this. It's a beautiful design for high energy environments. There's also where the same company also makes a net pen now that it is has more of that traditional circle, and so it's more cylindrical shaped. And that's something that we are in the proposal that we're putting forward for offshore of Ever Beach. That's the kind of net pen that we would like. It is still submersible. You can put it down 30, 35 feet below the surface if there's a storm coming or at night, but just when you're not working on them, just so that it's down in, like having the fish down in the deep, quiet blue. They're happier, I'm happier. And so those are the two kinds of net pens that we have a lot of experience with, that are available to us for offshore aquaculture. They're pen designs that are a lot more robust, a lot more sophisticated in their engineering than what the industry had 20 or 30 years ago. And this allows us to now move out into deeper water, further offshore, where you're more working with the ecosystem services. The oxygen you get is for free. The currents are exchanging the water. You're not having any direct impact on the coral reefs or the other fish around the pens.
So just some questions that are coming to my mind. Like how many fish end up being in one of these when you're raising them?
Well, that will depend on the size of the pen and the size of the fish that you're going to raise them up to. Generally, it'll be somewhere between 50,000 and perhaps 120,000 fish in a pen.
And then
And
how
then,
long does it take for them, like, let's just pick a fish, like how, I mean, to help you kind of give some numbers, just so people understand. And then how long does it take for them to get fully grown and then you would, you would take them out and what do
yeah,
you call it?
well, harvest them. You harvest
Harvest
them.
them, right? Okay.
Yeah. And when you say fully grown, Christina, that's like, fish just keep growing. This is the thing. They
Well,
won't
I
stop
mean, like,
growing.
I mean, there's certain fish, like, I don't know, kampachi, like certain fish, don't they just get a certain size? I don't
Yeah.
know.
And the kampachi will be like 5 or 6 pounds. So 2.5, maybe 3 kilos. They might be 7 pounds when they'll harvest that. And that's generally in around 12 months, maybe to get to 7 pounds. It might be 14 months. That's really rapid. That's why kampachi is a great fish to farm, just because of its really rapid growth rate.
Hmm.
But it requires a very expensive feed. It's a phenomenal product. Christina, you've eaten some of the farm's kampachi, right?
Hmm. Hmm.
I
Well,
mean,
I don't know.
it's,
Farmed, I don't know if I, my brother's a fisherman, so like when he comes home
well,
with fish, like, yeah, he's
yeah, well, he might
spearfishing
have come
stuff.
home with the kahala, which is the kampachi, what they call kampachi in the wild here. And kahala, generally, it's not eaten here in Hawaii. It's certainly not sold because it has a history of ciguatera, the natural reef poison that gets aggregated up, it gets
Hmm.
concentrated up the food chain. And that also internally it has parasitic worms, which aren't a problem for
Yes.
human
Yes, I
health.
remember this. He does. I mean,
Uh,
sometimes they do. Yeah. Okay.
yeah, and it's also, I mean, it's a good eating fish. It's kind of like a snapper. It's 5% fat content, which is nice. But when you farm the kampachi, it has no risk of ciguatera because you're completely separate from the reef food chain. It has no risk of the internal parasites, again, because you're separate from the food chain. And the fat content can get up over 30%.
Hmm.
And that's that really buttery, delicious flavor that you get from a farmed kampachi. Remember, when I say 30% fat content, a lot of that is the heart healthy omega-3 fatty acids. So that's the kind of fats that you should be eating. Your doctor's telling you should be eating more of those, Christina.
So, in addition to, I mean, I guess that's like, so when they're full grown or that you're going to harvest, there's like 50,000 fish in this net thing. Like it's pretty full. Now, I know that we're going to jump into limu at some point, and which for some of you may not, seaweed, and harvesting that and growing it. We can dive into that next, but with the fish that are in this little area, like I know, does it, where do you, how do you feed them? Are you like feeding them, or is it just there's stuff in there that they eat, or you have
No,
to,
no,
how does it
you
work?
have to feed them. You have to feed them, and you want to feed them a pellet diet, the same as you'd feed your dog or your cat that's been nutritionally formulated by a veterinarian to give the right balance of amino acids and fatty acids. And that's really critical. You don't want to just, there's not enough feed in the ocean there when you've got them in a pen. And B, you want to make sure that you're controlling the feed. And the feed is a significant, people are often worried about, well, you're overfeeding and you're letting the feed go. The feed costs over $2 a kilo. It is the biggest cost by far for an offshore fish farm operation. It's about 60 to 70% of the cost of producing that fish comes from feed. And so a fish farmer is going to be really rigorous in focusing on making sure that that feed is that you're feeding that to the fish that are going to be able to assimilate it quickly, that you're not overfeeding the fish, and you certainly don't want to have pellets falling out through the bottom of the pen. That's just literally throwing money away. And so you always want to keep the fish just a little bit hungry. And that's when they're going to, the kampachi will literally, they will literally make, metaphorically, I'm sorry. They'll make the water boil when they are being fed. It's just that they are really voracious feeders. And that's a wonderful sight to see. Sometimes, Christina, you should come down here and ask the farm operators if they can.
The next time I'm in Ireland, if I'm in Kona side, I'll come meet you. Okay. And then my other question I had was just, what about like, there's just this whole bunch of fish here and they're small, like, I don't know, I just think of a shark like coming after them. Like, do they ever try to swim around and check them out? I mean, I don't know. What do they do? Do they try to like bite through it, or what happens? I don't know.
Yeah, if you were a shark and there was this net
I
pen
mean,
full of
right? I mean, you
kampachi,
guys like, oh, it's a
if you're
gold mine. I mean, what do
if
you
you're a
do?
shark or a dolphin or an ulua, I mean, there is it becomes like an oasis. A net pen in the offshore environment becomes like an oasis. And yeah, there are like any other oasis or any other structure in the water, there's going to be other animals around on the outside. That's the natural part of the ecosystem. The key is, as they say, good fences do good neighbors make. And so the key is in developing the net mesh that is resistant to this. And so there are, back 20 years ago when we first started the net pen operation here off Kona, we were mainly using nylon netting, and there were some issues there with sharks that could bite through that nylon netting. But in the intervening 20 years now, they've developed a copper alloy mesh. So it's like a chain link metal mesh that's on the underside of the cages, and that is very, very robust. And then there's also on the top of the net pens, they use a polyethylene terephthalate. So it's a very, very strong form of plastic. And they use, there's a mesh material of that they use as well. And I first, when I first came across that Kiko net, it's called a black mesh net. It had been used in Japan for like 25 years, but there's only one farmer outside of Japan that had been using it. He was a barramundi farmer down in North Queensland in Australia, and I called him up and was talking to him about it. And he was like, yeah, it's bloody crocodile proof, mate. So if an Aussie is telling you it's crocodile proof, it's pretty robust stuff. And it
Awesome.
really is. It's wonderful. So ever since that, they've been using those materials on the offshore farm, and we'd started that transition there. Also down in Mexico, we were using the Kiko net down in Mexico. It's a wonderful thing to be able to keep. You want to always have, it's fundamentals for fish farming. You want to keep the sharks on the outside and the fish on the inside, and don't get them confused, please.
So it's basically just window shopping now for these big fish that swim by and can't get it.
Well, then there's a lot of other bait fish, pelu and akule and other little bait fish that are around the outside there as well.
Are they small enough
In
to get
Kona,
through?
yeah, but they don't get through in
Yeah.
yeah, it'd be pretty dumb for them to swim inside of that. And there is actually here in Kona, one of the Apelu fishermen regularly comes and fishes up close to the net pens here because he knows that's where the appella are going to be. That's really, for me, I really love that commercial fishing folk are starting to see the benefits of offshore aquaculture.
Interesting. Okay, we don't have a lot of time left. We've been just trucking away here. Let's dive into limu. And so what you're doing there on growing the seaweed. Can you tell us what you're doing, how you're doing it offshore? I know have been working with like Herb Lee out at their farm. Actually, it's not a farm, it's a old fish pond on the windward side. And I know that they've been doing a lot of testing and growing limu because the, you know, sea the sea level changes and the temperatures of the waters have really affected their area and the type of things that grow there. The limu that normally grew there doesn't grow there anymore. It's changing like the ecosystem. And so I know they're doing a lot of testing and then they grow it in things outside of the water. So I was curious to hear how you guys are doing with growing the limu in the oceans and stuff.
Yeah, at the moment, well, almost all of our limu trials have been in land-based tanks here at the Natural Energy Lab. We really like the idea of farming more limu because that's getting us closer to the base of the food chain, both for limu that we can eat, but we're also looking at growing limu that we could be feeding to fish. We've done a lot of work with nanue, which is an herbivorous fish. It's a fish that you see out on the reef, a silver fish that'll be actually up in the surf zone on the reef frequently, and they make a living turning seaweed into sashimi. That's their primary diet is seaweed. They'll be up grazing on the reef there. So we think nanue is a wonderful fish to farm because you don't need to put a lot of fish meal or fish oil in the diet, probably none at all. We've been feeding them with a tilapia diet, and they taste like a snapper when you feed them a tilapia diet. It's really clean. It doesn't have that strong limu flavor that some
Hmm.
people don't like. I like nanue because it's got that strong flavor. Most people don't enjoy it that much, but when you feed it on a tilapia diet, it's really clean, fresh taste. And generally, tilapia feed is very little protein and oil. It's mostly carbohydrate because tilapia are also primarily herbivores. And so philosophically, we as a company, we want to be striving to be less impactful. Our mission is to soften humanity's footprint. A big part of that is just growing more seafood because, as we've talked about, seafood's less impactful. But then if you're going to be growing the seafood, it's less impactful if you can move down closer to the base of the food chain. So that then you're feeding the plants, the limu, directly to the fish. Or perhaps you could also be feeding the limu to pigs or chickens or cows as
Mm.
well. There's couple of companies here at the Natural Energy Lab in
Cows.
Kona
Huh. I
that
haven't heard of
are
that
working at,
before.
they're looking at growing limu kohu, which is asparagus. It's a red seaweed. They're looking at growing that to feed it to cows because then it suppresses the methane production in the cow burps. Cows
Hmm.
burp a lot of methane out when they're
Yeah, right.
ruminating. So you feed them a little bit of this asparagus. So there's a lot of potential. Limu is phenomenal. If we could figure out the economic drivers to expand limu production, the world would be a lot better place. If we were farming more seaweed, then there's tremendous environmental benefits, increased productivity, increased biodiversity. There's great socioeconomic benefits because a lot of the seaweed farming can be in remote areas where there's very little other possible forms of employment. We've got to figure this stuff out. It's nobody's ever done it before. We find that that challenge, we relish that challenge. But so we've been growing some of the limu we've been growing. We've been putting into the food service, into restaurants, particularly on Maui, the ground wailea on Maui. Mama's Fish House on Maui was also a big customer before the fire. And then we've also been selling it in retail at the local KTA stores here on the Big Island. And this is one that's called the sea grapes. It's Kalerpa, or the Japanese name for it is umibudo. And it's a phenomenal mouthfeel. It's like caviar, vegan caviar, we like to think of it. We've also been growing ogo and growing some of the other native limu species here that haven't been farmed commercially before. Limu lepe hina, or the shawl of hina, is a red seaweed that we think has got a lot of potential, Halimenia. And so the work that we've been doing up to now has just been in land-based systems. We are hoping to be able to move out offshore and do an experiment here in Kona, where we would be using the deep seawater to get the nutrients for the limu. Part of the challenge for growing limu in the tropics, beautiful blue water here in Hawaii. The reason it's so beautiful blue is because it's a desert out there. There's no nutrients in it. It doesn't have a lot of green in it. So to get the nutrients, you can either take the limu down to deep water and let it soak up the nutrients there, or you could be farming them close to fish. And this is what we're proposing to do with our Ever Beach proposal, that we would be farming fish, moi. There was originally a moi farm out off Ever Beach. That
What happened to
everybody,
that?
it's shut down in I think around 2014. And nobody's gone and started it back up again. So we'd like to be farming moi and nanue, and also kampachi there, because I think Oahu needs it, to have more fresh kampachi into the market there. And then if we're going to be farming the fish, we'd like to down current be farming the limu that could be going both into the human food market and potentially also into the animal feed market there in Oahu. So that's our proposal that we've been for about the last 4 years. We've been
Wow.
airing this.
How long does it take to get this through?
We're taking our time. We're wanting to be conscientious in our outreach to the community and making sure that we're talking to everybody that wants to listen, and that we're getting the right information to people, and we're getting that information reflected back to us, their concerns and their questions back to us, so that we can address those as well. Now, we could have gone and rammed this through and said, here's a proposal, take it or leave it. No, that's not the way that we like to work. We want to be consultative in the way that we work with our community.
Awesome. Okay, well, just a little bit before we jump off, what are some ways that people can reach you if they would like to ask more questions, perhaps? What's the best, did you want to share your email, website, Instagram?
Yeah, best to reach out to us through our website, which is ocean-era.com. Or you could email me directly, Neil, Neil, at ocean-era.com.
Okay.
I'd be happy to
And
hear from folk who have
yeah,
questions or
they
would
have
like to come and
Instagram as
start a
well.
career in aquaculture.
Yeah. And if you happen to be in Kona, you could give them a call and check out some of their farms and what they're doing over there. Let's see. I think that's just about it. We're hitting on an hour here, so I don't want to take any more of your time, and I know we covered a lot. If anybody has any more questions, you know how to reach Neil. And then check out their website. It does have a lot more diagrams and visual aids to help you to see exactly what these like sea stations look like. It's very interesting. I've never seen how, I haven't really dove into farm raised any kind of fish, so I don't really know how it is on the ocean side, more on the land for me. So it's been very educational. So thank you so much, Neil, for your time and for joining us, and for all the work that you're doing to make sure that farming fish and limu is going to be more sustainable for our future. Until next time, stay and live smart. Also, you can check out our podcast on www.smartlivinghawaii.org. And then you can also check us out on Instagram and Facebook as well. Until next time. Mahalo. Bye.
Thank you, Christina. Aloha. I'm gonna